Good morning students. Last class we have seen exercise 2.2 first Roman. This is continuation of exercise 2.2 second problem. What is given in the second problem? See, given the complex number z equal to 2 plus 3i. Represent the complex numbers in the Argand diagram. See, one complex number is given z equal to 2 plus 3i. So we are going to represent the complex numbers in Argand diagram. The complex numbers are z, iz and z plus iz. See, last class I have explained already Argand diagram or Argand plane I have explained already. So what is Argand diagram? Do you remember anyone? Okay, let me explain. So Argand diagram is nothing but, see, consider x-axis, y-axis, consider this x-axis real axis and this is imaginary axis. Now if we plot one complex number, see, this is a complex number. Any complex number can be represented as a ordered pair. So what is the ordered pair of this complex number? 2, 3. 1, 2. So x-axis 2, y-axis 3. So the point is 2, 3. So now we are plotting one complex number in this real axis and imaginary axis plane. So this is called a Argand plane. So if we plot so many complex numbers as we join this point, we get one diagram. This diagram is known as Argand diagram. See, once again I explain. So if we plot complex number in this plane, we got one diagram. This diagram is known as Argand diagram. Okay. Now here three complex numbers are given. Z, IZ and Z plus IZ. We are going to represent these complex number in this Argand plane. Okay, first Z already given 2 plus 3. What is the second complex number? IZ. So next we are going to find IZ. IZ is nothing but Z is multiplied with I. Okay, so now I is that 2 plus 3i. Just you multiply these two. I into 2, 2i, plus into plus 3 into I squared. So 3i squared. Already you know value of I squared is minus 1. So minus 1 into plus 3, minus 3. So I is that equal to 2i minus 3. Next, what is the third complex number? Z plus IZ. Next we are finding Z plus IZ. Z 2 plus 3i and IZ 2i minus 3. So now in the place of IZ you write 2i minus 3. Now add like terms, real numbers and imaginary numbers. 2 minus 3 minus 1 and 3i plus 2i 5i. Now we got Z plus IZ equal to minus 1 plus 5i. Now see, Z equal to 2 plus 3i. It is a complex number. We are going to plot this complex number in Argand plane. Before that, what is the ordered form of this complex number? Yes, 2, 3. Now what is the ordered form of this complex number? 2, minus 3. What is the ordered pair of complex number? This complex number? Minus 1, 5. Now we got 3 points. 2, 3, 2, minus 3 and minus 1, 5. Now we are going to plot this point. See, what is the first pointer? 2, 3. So now you plot this point. X-axis 2, y-axis 3. So this is 2, 3. Now next, second point is 2, minus 3. Sorry, this is, first we have to write real part, no? Minus 3 plus 2i. IZ. Real part plus imaginary part, because the standard form of complex number is x plus I, know. Always first one real part and imaginary part I, x plus I. So first we write real part, then you write imaginary part. So this can be written as minus 3 plus 2i. Now see, one thing you should know, if you change, say 2, 3 is not equal to 3 comma 2, isn't it? So we should be very careful in this. So what is the ordered pair of this complex number? Minus 3 comma 2. Now plot this point in this organ plane. X-axis minus 3 and y-axis 2. So we get minus 3 comma 2. Okay. Now third point, minus 1 comma 5. So x-axis minus 1 and y-axis 5. We get this point. Now join this 3 points. So we get one diagram. What is this? It's nothing but right angle triangle. Therefore, Z, IZ and Z plus IZ forms a right angle triangle. Have you got it? Once again, I recall the problem. One complex number is given and 3 complex numbers given. We are going to represent this 3 complex number in organ plane. So first you have to find all the 3 complex number. After finding, just you plot a point in this plane. You got a organ diagram of this one. Okay. Shall we move to next problem? Okay. Third sum. What is given in the third sum? Find the values of the real numbers x and y. Find the values of the real numbers x and y. If the complex numbers 3i into x minus bracket 2 minus I into y plus 2i plus 5 and 2x plus minus 1 plus 2i into y plus 3 plus 2i are equal. See what is given this problem? They are asking to find the value of x and y. One condition is given. What condition? These two complex numbers are equal. Okay. See, if these two complex numbers are equal, then you have to find x and y. Okay. Now, actually mathematical concept is always known to unknown. So, this is the known value. From this, we are going to find the unknown x and y. Okay. So, what is the known one? These two complex numbers are equal. Okay. So, this is given. And to find x and y. Okay. Solution. According to the given condition, these two complex numbers are equal. Therefore, we are equating this complex number equal to the second complex number. Okay. Why we are equating this one? Because they have given two complex numbers are equal. Okay. Now, just you recall the previous class concept. What is that? If two complex numbers are equal. What is the concept? If two complex numbers are equal means automatically corresponding real parts and imaginary parts are equal. So let me explain small example. X plus iy equal to 2 plus 3i. See these two complex numbers. From this, how can you find the unknown x and y? So the concept is two complex numbers are equal means corresponding real parts are equal and corresponding imaginary parts are equal. So the value of x is 2. Here the value of y is 3. So this is simple complex number. So easily we can find x and y value. But here it is not like that. So first we have to write in x plus iy form. That means one real part plus one imaginary part. Before that we have to simplify this. Okay. How can we simplify this? It's nothing but ordinary addition multiplication, isn't it? Okay. Now just you multiply this. 3 into x, 3x. Minus into plus, minus. I into x, ix. Okay, next multiply this term, second term. Minus 2 into y, minus 2y. Here minus. So if we multiply minus into minus, plus I into y, plus iy. Now this is no bracket. Just we write as it is 2i plus 5. Similarly, we have to simplify this complex number. 2x. No, nothing is here. So just write as it is 2x minus 1 into y minus y. Here plus into plus 2i into y 2iy or I 2y because multiplication is commutative. Okay. Now this is you write as it is 3 plus 2i. Okay. Now see here 1, 2, 3, 4, 5, 6 terms are here. Just you group real part and imaginary part. What is real part? If there is no I means here, there is no I means only number is called a real number. No. So here 3x, here I, here 2y. So this is real number, this is imaginary because I is here I is here. So this one. So just we group real part. Okay. So what is 3x minus 2y plus 5. Now group, we are grouping real parts. Then group imaginary parts. So imaginary parts you take I, because always the general form is x plus iy. No, just you put plus and I, you open bracket. What is imaginary part of here? Minus x. So you write minus x. Here plus y. Here plus 2. Okay. Similar, the same way, here you group real part and imaginary part. 2x real part because there is no I. Here minus y. Now 3. So 2x minus y plus 3. This is real part. Next group imaginary part. I 2y, 2i. You take I outside. Then write remaining 2y. Here plus 2. Now here we have written this as x plus iy form. Here also x plus iy. Now this is like x plus iy equal to some complex number. This is one complex number equal to another complex number. So two complex numbers are equal means corresponding real parts are equal, corresponding imaginary parts are equal. Now we are equating real and imaginary parts. What is the real part? 3x minus 2y plus 5. Real part of this is 2x minus y plus 3. Just equate. What is the imaginary part here? I part minus x plus y plus 2. Here 2y plus 2. So just equating the imaginary part. This is real part. Now you simplify this. Okay. How can you simplify? Just bring variable one side and constant one side. That number one side. Now here if you bring 2x to the left hand side, it becomes minus. If you bring minus y to the left hand side, it becomes plus. Already 3x minus 2y is here. Next to bring down this 5 to the right hand side, it becomes minus 5. Okay. Now add like term. 3x minus 2x, x. Minus 2y plus y, minus y. Because this is the biggest number, so that's why we are putting minus here. So if you subtract this, we will get y. So x minus y. Here 3 minus 5 minus 2. Consider this as equation number 1. Next, solve imaginary part. Same way. Bring y this side and constant this side. Minus x plus y. Here minus 2y. If you bring this 2 here, 2 minus 2. Now simplify this. There is no x. Only one x is here. Just write as it is. Minus x. Plus y minus 2y minus y equal to 0. So always first term should be positive. So just we are multiplying to remove this negative sign. We are multiplying this equation by minus 1. So minus 1 means we will get x plus y equal to 0. Consider this as 2. Now we get two equations, 1 and 2. These two are linear equation. Already you have studied in 10th standard, isn't it? Now solve this two equation by elimination method or whatever. So here I am using elimination method. Now x minus y equal to minus 2. First equation. Second equation x plus y equal to 0. So now cancel this. Now x plus x 2x. Already sign change so easily we can cancel. Suppose if both numbers are both variables are same means just we have to change the sign here. Already changed so no problem. Just you add this x plus x 2x minus 2 plus 0 minus 2. Now 2x equal to minus 2 means x is equal to minus 2 by 2. If we cancel we get minus 1. So the value of x is minus 1. Okay. Now we got x value. Now next we have to find y value. You have to substitute this x value either this equation or this. It is your wish. Here I am substituting this value in second equation. Now substitute x is equal to minus 1 into we get, see this is the second equation, x plus y equal to 0. In the place of x you substitute minus 1. So minus 1 plus y equal to 0. Now bring this minus 1 to the right hand side. It becomes plus 1. So y equal to 1. Therefore, value of y equal to 1. Therefore, the values are x equal to minus 1 and y equal to 1. So, this is a very important problem. Sometimes they may ask in 3-mark question. Once again recall, here two complex numbers are equal, they given, and they find x and y value. So, before that, usually it is given complex numbers are equal. So, we are equating this complex number. It is not in the standard form x plus iy. So, we are simplifying to get that as x plus iy form. So, after simplifying, we got two complex number in the form of x plus iy. Here also, we know two complex number equal means corresponding real parts and imaginary parts are equal. So, here we are equating real parts and imaginary parts. After equating, just you simplify this, we get two equation. Now, if we solve this two equation, we will get x and y value. Now, homework. In second Roman, they given two problems. One problem I have done, second problem is homework. Similarly, third one, this is homework. I hope you all will complete this problem and you have to write all this in your notebook. One day we will call you for note correction. Okay, so next we will see you in the next class. Thank you.